Right. Electrostatic field. Our first equation, two charges Q1 and Q2. The separation between them is R. So the force F, first equation, F equals 1 over 4 pi epsilon naught Q1 Q2 over R squared. Second equation, force per unit charge equals 1 over 4 pi epsilon naught Q1 over R squared. Third equation, that's potential. Let's say V 1 over 4 pi epsilon naught Q over R. Potential energy, let's say P dot E 1 over 4 pi epsilon naught Q1 Q2 over R squared. Right. Fifth equation. Right. Now we can combine these two equations. First two equations, F equals E Q. The last two equations, W work equals VQ. Then we are moving into capacitors. First type of capacitors we have parallel plate capacitor. The distance between them, the plates, distance between the plates D, common surface area A, and in between we have epsilon naught medium. So the equation, then the capacitance Q equals A epsilon naught over D. Then we can combine the capacitors in circuits in parallel like this with a cell, and then the equivalent capacitance we can take it as C. If this is C1, if this is C2, then C equals C1 plus C2. Then we can connect these two in series in a circuit like this. Right. Then this is C1, C2. The equivalent cell, let's take it as C. 1 over C equals 1 over C1 plus 1 over C2. Then the charge of the capacitor Q equals CV, and the energy E equals half VQ. First equation, again E equals half CV squared. Second equation, again E equals half Q squared over C. Third equation. Right. Then there's another spherical capacitor. The radius is R. Then C equals 4 pi epsilon naught R. Then we have Gauss laws. Flux, total number of field lines equals Q divided by epsilon naught. Then the flux density, phi divided by area, that is equal to electric field intensity. E equals, once we combine these two equations, Q over A epsilon naught.